Hello, champions. Welcome back to Math Bison. In this video, we are going to look at another interesting topic in mathematics. That topic is what? Lines of symmetry. In this video, we are going to look at what lines of symmetry are. So I'm going to show you the tricks and the ideas behind lines of symmetry in this video. So hang on and let's get in shortly. All right, welcome back. Before we continue, I would like to do a bit of an activity with you using this paper. This paper that I have is an A4 paper. And as you can see, the A4 paper is, which shape is it? Is a rectangular shaped paper. When we talk about lines of symmetry, usually we're looking at a line that can divide the shape into two equal halves. They're not just going to be two equal halves. They have to be mirror images of each other. This one is the key term in lines of symmetry. So there's a line that will cut this paper into two equal halves such that if you fold the paper in through that line, one half will cover the other half, point for point. What do we mean by point for point? We're going to understand that shortly. Now, I'm going to go ahead to fold first this way. After folding, making sure that the edges match. Now look at what we have here. Look at what we have here. There's a line in the middle now. This line divides this paper into what? Two halves that are equal. Because they are equal, you know they are equal because if you look at this closely, they cover each other, edge for edge. You know, nothing is popping out. And it's as if it's just one side that I'm holding. And of course, it's just because the two halves are perfectly folded such that they cover each other properly. Now, look at when I said point for point. This point, they match. This point, they also match. This point, they also match. And this point, they also match. They overlap properly. Now, this is a line of symmetry. Just for two reasons. One, the halves are equal. But it's not enough that the halves are equal. They must also overlap properly, perfectly, point for point. This is what we call mirror image. If, for example, we have a big mirror. We have a big mirror that is we can place on this line. Okay? I mean plain mirror now, like the mirror we have on the wall in the house. If we have a piece of it that we can place on this line, what's going to happen? If we look into the mirror, there's an image that will form. That image is going to be the image of one of this half. And that image inside will be equal to this part. It's like I have created this part from that image in the mirror. This is what is mirror image. Always think about mirror image when you think about what? Lines of symmetry. Now, we found one here, one line that helps us to divide this paper into what? two equal halves that are what? The same. They are equal and they align, they overlap properly on all points. Let's try another direction of folding. Now, this time around, I'm going to fold it this way. If we fold this way, let's make sure that everything is cool. So this activity is something you can actually try by yourself. Just get this paper and try to create the lines of symmetry by yourself. Now we have this, and by this fold, you see that we have two halves, and the two halves cover each other perfectly. Remember, on all points, look at here, they cover properly. Here, they cover properly. Here, they cover properly, and here they also cover properly. This is why they are considered to be what? Mirror images of each other. This one mirrors the other one. This one also mirrors this one. You really need to understand mirror image. When you put a mirror on this line again, on this line, and you see that what you have inside is similar to this paper on this side. So this mirrors this side, this mirrors this side. Now, when you have a line like this that mirrors the two halves, makes the two halves equal and also mirror images. They are not just half, they are also what? Mirror images. You can never understand, or you can never be right with lines of symmetry if they are just equal and they are not mirror images of each other. It's not a line of symmetry. Now, how many have we had so far? Remember, we are still dealing with a rectangle. We have one, and we have the other one, two, which is the second one. Then you may want to think, oh, which other ways can we fold this paper? We can actually use the diagonals. There's usually another fold that is through the diagonal. So let's try the folding through the diagonal of this paper. Okay, I'm done folding mine. And this is what I've got. This is what I've got. Now you're going to understand better what line of symmetry truly is. Look at this. We have two equal halves. These are equal. This half and this half are equal. But they are not mirror images of each other. Why? If it's a mirror image, number one, you cannot see any part of the second half when you view from one side. Look at when we folded from here, you will only see one half because the one half is covering the other half perfectly. Because one half is covering the other half perfectly. But now look at this. This does not cover each other. These two halves do not cover each other perfectly. So we do not have this part on all points is not covering the other point. Look at this. We have here, this place is supposed to be on top of this if they are going to be lines of symmetry. You're not supposed to see this part of the part closer to me. Imagine if I want to fold it out, the excess, the extra, there are extra you are seeing. Look at it. This extra is not supposed to be there. And on this side too, this extra is not supposed to be there. This extra is not supposed to be there. So this is why this line is just a diagonal line. Is this a diagonal? Is it a line of symmetry? No, it's simply what? A diagonal line. That's fine. So we can say that, we can conclude that in a rectangle, we only have what? Two lines of symmetry. Only two lines that can split the paper or fold the paper in two, such that one half is equal to the other and it covers completely on all sides without seeing any part of the other half that's on the other side. So this is line of symmetry. Now let's go on the board and have some drawings for better understanding of lines of symmetry. All right, welcome to the board. I'm going to have a big mirror here, and we'll try some shapes. So lines of symmetry. Lines of symmetry. Symmetry is what? It's actually a balance. 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 Symmetry. It is very artistic, and it's a true reflection of a balance. You know, when you're watching Taj Mahal of India and you see all the shape, the way left side is balanced with the right side, you can go check it out. You're like, wow, this is magnificent. That is the power of symmetry. Let's look at a rectangle. The first shape we're going to look at is the rectangle. 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 The one we drew, the experiment we did, or the activity we did, we know that a rectangle can only have a split from here, such that this side will be equal to this side. Or we split this way, such that down here is the same, and they cover each side. So this is the first line of symmetry, and this is the second line of symmetry. So there are just two lines of symmetry. These two lines of symmetry, what do they do? The lines that folds, or the lines that fold the shape, remember folding the shape into two halves which are what? Which are mirror images of each other. You need to go get a mirror and feel the symmetry, power of symmetry. Now let's check a square. As for a square, if you have a square, it's easy to see that you can cut through like this, and this folding towards this side. Okay, if you fold them inwards, what happens? This side will cover this side properly. So the diagonals are also giving that symmetry you want. And it's not just that. From the side, we can also break it horizontally into two equal halves that are symmetrical. When I say symmetrical, just keep thinking about mirror images and two equal halves. Two equal halves that are mirror images. Let it be ringing in your mind. They have to be mirror images. They have to cover each other perfectly, point for point. Now, we have 1, we have 2, we have 3, we have 4. I don't have to count this one. Remember, it's simple as the 1, 1, 1, 2, 2, 3, 3, and the 4, 4. So there are what? In the square, there are 4 lines of symmetry. Yes, we're moving. The next one is going to be a circle. Does a circle, how many lines of symmetry does a circle have? I'm curious. We are told that a line that divides a circle into 2 equal halves is called what? Which passes through the center and is 2 equal halves is what? Is a diameter. It's a diameter. And that diameter is also a line of what? It's a line of symmetry. And this is because it also fulfills the requirement for a line of symmetry. It also divides the circle into 2 equal halves that are mirror images of each other. Any direction you choose to draw the diameter, it is always going to split the circle into 2 equal halves that are what? Mirror images of each other. Fortunately, I think fortunately the circle is a very unique shape when we discuss lines of symmetry, because the number of possibilities for a circle is actually endless. The diameter can be drawn from any position. As long as it passes through the center, it continues like that. And every diameter you have is a line of symmetry. So if you keep counting, you might be there till next year and you just get tired and you just leave anyway. So the lines of symmetry in a circle is infinite. It cannot be counted. There are just endless possibilities. Infinite, endless possibilities. All right. The last one I'm going to talk about before we try some things on the image, on the mirror, will be, let's take an equilateral triangle. It's a type of triangle that is what? Equilateral. Equal lateral sides. Okay? The type of triangle that has all its sides equal. Okay? This is it. So we used to mark the sides this way to show that what? They are all equal. The lines of symmetry in an equilateral triangle, let's try. I need to look at it as, okay, I'm going to fold this paper or this shape in a way that everything on the left will cover everything on the right perfectly. And this is going to be only if I use the angle here. If I draw through the angle here, then you will see that this half and this half are just like left and right halves that can fold. When they fold, what's happening? This edge will eventually cover this edge and everything will be perfect like that. So this is number 1, line of symmetry. Again, if you look at it from this other corner, We can also draw same through this corner too, and you have a second line of symmetry because this side, okay, this side here will also fold and cover this side. Now there's still one more. Through this corner too, through this corner, through this corner, we also have this third line that splits the shape into two equal halves also, and they cover this edge, we cover this edge, and it's going to be perfect on all points. So we have three lines of symmetry. So in an equilateral triangle, we have three lines of symmetry. This is different when you try an isosceles triangle. The isosceles triangle has only one direction that can isosceles triangle. The isosceles triangle is like this. You will see that the sides are not equal. So down here is short, and these two other sides are equal and they are longer. Because of that, we also have an angle here and an angle here that are base angles that are equal, and this third angle here is not equal to the other two. This is a typical property of the isosceles triangle. Now, there's no how you're going to draw a line from here, and you can obviously see that one part is bigger than the other. But if we draw a line from the top here to the center, we'll get a perfect symmetry. So this side we fold to this side and cover it perfectly, covers perfectly on all points. Exact. So we have just one line of symmetry. Now, to conclude this video, I'm going to show you something that happens inside the mirror, the word in the mirror. Let's see the word, the shapes in the mirror. So shapes in the mirror. So let's assume that we have this plane shape, plane mirror on this side. And this is the face of the mirror, and this is the back of the mirror. In physics, we use this dash to denote, to indicate the back of the mirror. Now, being plane mirror, what happens if I draw a shape on this side? Take, for example, we have this. We have this, we have this, and we have this. What do you want to see inside the mirror? Inside the mirror, this space between the mirror and this figure will also be there. You will see that that shape, that space is there. The mirror image will look like this. Starting from here, you see, the parts closer to the mirror will be same. The parts farther away from the mirror will also be same. You see, this is the object and this is the image. Okay, it's a real image and is what? Mirror image. This is what we call mirror image. Look at it. It's like the balance you get in a butterfly. You see, if you have a butterfly, let's say you have half the body of a butterfly on this side. with the abdomen, and you have this wing this way, okay, and this way. Once it's placed with the mirror image will also be this. The parts close to the mirror will be same, and the parts further away from the mirror will also be same. Then, so this part is a mirror image of this part. This is the world in the mirror. Now, if you are thinking that you have a shape like this and a shape like this, and this is happening to be a circle, like the cone of an ice cream, and you see that that shape is coming on this side. If you draw it like this is a very perfect mistake. That mistake is perfect because this is not a mirror image. While this may look like, oh, they are equal, yes, they can be equal, but if they are not mirror images, then there's no line of symmetry. So now look at this. From the left, the part tending towards the left. As you go towards the left and you go towards the right, you have to have everything in the same position and in the same direction. Okay? So what you can have that makes sense here will be that this is the mirror. If you have this shape drawn here, then on this side of the mirror, inside the mirror, you must also have the shape come out like this. Yes, look at it. It looks like wings of a butterfly. Then in this direction, we say that they can cover each other. They are not just from this folding. We don't need to move it. We just fold it from this center. If you fold it by this center, this part will cover this part. 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 This point will cover this point. Here, this curve here will cover here and here. Here will cover this. Here will cover this. And this point will cover this point. And what next? Here we cover this. All of this we cover. Look at the way the symmetry works. This is what we call line of symmetry. So this position where the mirror sits, or this line which the mirror is sitting on, is the what? Line of symmetry. That is the line that divides, that folds, remember, folds the shape into two equal images that are mirror images of each other. They cover each other perfectly. Now, we can have shapes like this, and you're just asked to find mirror images. If I draw a shape like this, and I say, what's the mirror image of this shape? Think about sharing. Think about a line. Think about the mirror. Think about a line you are drawing somewhere midway, such that the shape left can be folded. It's like a fold you're trying to make on the shape, such that the left side, right side are what? Equal and mirror images of each other. If you try this side, you see that what you have up on the upper side is entirely different from what you have on the lower side. Even if you feel or you have a sense that they are equal, They cannot. Now let's try our bottle of maybe it's a drink. Okay. 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 What if? So which line can we draw on this shape that will make it, that will be a line of symmetry? It has to be the line which folds this shape into what? Two equal parts, two equal halves that are what? Mirror images. If you do this, even though it may seem like you're in the middle, this is different from this. This part is different from this. The upper part is different from this lower part. They cannot fold to form mirror images of each other. But if we do this through the center, it's like using the sword to slice the bottle into two equal halves, the longitudinal cut, like that of the cut that folds the shape into two equal halves, such that everything you are seeing on the left hand side is equal to right hand side, and they are what? Mirror images. Mirror images. Do not forget mirror images. Even if they are equal, if they are not mirror images from the fold, not just from anywhere, from the fold, because if you look at this part, if we cover this with this, it's going to be equal, but you have to move it like another object and put it on top of this. No, it has to be through a folding process. If you fold from here to here, what you are having is going to be this. If you fold like this, doesn't mean you fold like this from here. This can never cover this part perfectly, not mirror images. So this line is not symmetry. It's same like the most important and the key word that makes you get your symmetry line figured out easily is you looking out for what? A fold that is looking out for a fold on that image, how you can fold that image such that the two halves will fold to cover each other perfectly, like the wing of a butterfly, the way it can fold and it will cover each other perfectly. Even the spots on the butterfly can also be same. So thank you for So we've come to the end of the video on lines of symmetry. So we've come to the end of this video on lines of symmetry, and I hope that your understanding of lines of symmetry is clearer and is better, and it's going to help you as you proceed in your math journey. Thank you for your time. Please share, subscribe, and watch our next video. Thank you.